Hello. So thank you for watching this lecture video. So today is Thanksgiving Eve. So many of you just prefer lecture video. So in this way, you can save some time to you have some enough time to preparing family gathering, right? And you can watch this video in your spare time. So this maybe is more convenient for you. Okay. So anyways, thank you for watching this lecture video. Okay. Uh, so last class we discussed some trigonometry identities. So we say even though we have six trigonometry functions, sine, cosine, like we have six trigonometry functions: sine, cosine, tangent, cotangent, secant, cosecant. Right? But basically, most important are sine, cosine, because all others can be written in terms of sine, cosine. Like tangent equals sine over cosine, like cotangent equals cosine over sine, right? So secant is 1 over cosine and cosecant is 1 over sine. So, so from here we say we can write all those six trigonometric functions in terms of sine, cosine. So use those relationships, we can simplify some trigonometry expressions. Like here, so we also can call those as um, call those as identical proof trigonometry identities. So basically they are the same. Like on the other side, we can simplify then to the other side. So we say, oh, so the two things are essentially the same thing, but only in different forms. Right? And for sine, cosine, so we say most important are sine, cosine. So for sine, cosine, so we have this relationship: the sine square plus cosine square equal 1. Okay? So this is equivalent to a square plus b square equals c square, right? So for right triangle, we have this a, b, c. Then for this angle, we have a square plus b square equals c square. So in terms of sine, cosine, this relationship become sine square plus cosine square equal 1. Okay? Okay. So we say this is a very important relationship between sine, cosine. And use this, we can change cosine square. Like we also can, from here, we can produce some others. Like we can change cosine square in terms of sine square, right? And sine square in terms of cosine square. Okay. Okay. So this is a very important relationship, just like a square plus b square in c equals c square for large triangle, right? And for sine, cosine, we find we have some other relationship. So let's check this large triangle again. So we say like this angle's sine, basically this angle's sine equal this angle's cosine. Okay? Okay, so for large triangle, we say, okay, oh, maybe this is not so, okay, oh, this is not, the graph not so good. We say this angle's sine equals this angle's cosine. And this angle's sine, the cosine is this angle's sine. And this angle's tangent equals this angle's cotangent. So we call those co-functions. So we say sine and cosine are co-functions. So coming together, the two functions quite closely related, right? So we call those co-function relationships. Okay, so we say that this angle sine equals that angle's cosine. Okay, so this angle, so if this angle is theta, then this one is pi over 2 minus theta, right? Because these two angles together is pi over 2. Okay, so in general we can say like not from right triangle, we can say sine this angle equal sine. This angle cosine equals that angle cosine, and this angle cosine. This angle cosine equals this angle sine, and tangent equals this angle cotangent. Okay. Okay. So from here, we can we have this. Let's say like sine pi over 2 minus theta. This one will become cosine. Okay, so this means sine alpha sine x minus sine y is not equal sine minus sine. So don't make this mistake. Sine, let's say sine generally or sine this angle minus that angle. We say this not equal just sine minus sine. Okay. So don't make this mistake. And we also, from here, we also can say like sine function is not a linear function. Only linear function we have this. Like so many functions not linear. So for example, like let's say like square root, we say the square root for a minus b not equal square root a minus square root b, right? Okay, so we all know this. And let's say like a minus b square, so not a square minus b square, right? Not equal a square minus b square. So we say many functions are do not have a linear relationship or not linear function. Okay. Okay, so then we have this question like sine alpha minus beta or sine x minus y is not equal sine minus sine. So then equal what? Okay. So today's topic is just answer this question. So cosine x minus y, the cosine is also not equal cosine plus minus cosine, or cosine x plus y not equal cosine x plus cosine y, right? So we have those questions. So what is those equal to? So we wanted to find those formulas or identities. Okay. So this is today's topic. So we just listed those formulas. So we have this. Okay. Sine alpha minus sine alpha plus beta so equals sine alpha cosine beta plus cosine alpha sine beta. So I remember this way, like sine alpha plus beta, sine alpha plus beta equals sine cosine, then plus cosine sine, right? So sine cosine, sine cosine, cosine sine, okay? And cosine alpha minus cosine alpha plus beta equal cosine cosine, so minus sine sine. So cosine alpha minus beta equal cosine cosine plus sine sine. Okay? So we say once we have sine's formula, we can get all others, right? For example, tangents for tangent. Tangent, we can regard tangent is equal to sine over cosine. So actually, from this relationship, we can get the formula for tangent alpha plus beta or tangent alpha minus beta. So sometimes so we just listed here. So we just use these formulas. We don't need to drive them again and again, right? So here we also listed here the tangent alpha plus beta and tangent alpha minus beta. Okay. So we call those formulas as sum of difference formula. Sum of difference. Sum of difference formula. Okay. So sum means alpha plus beta. Difference means alpha minus beta. Right? Okay. So so with this formula, what we can do? So let's talk about this application for those formulas. Okay. So basically, just if you give me alpha, the applications of those. If you give me two angles, like we can find others. So we can call those problems as give me two or giving two. Like if you give me two angles, then we can find their sum or difference. Okay. So let's check this a typical example. Like we have two angles, alpha. So we would I will not tell you directly like alpha is 30 degree or beta is 40 degree, not like this way. I just tell you like, oh, alpha, I just only know sine alpha equals this. And beta, I just tell you cosine beta. Okay? So in this way, I give you some information about alpha and beta. Then I will ask you find there are some alpha plus beta sine, or alpha minus beta cosine, or alpha plus beta tangent, alpha minus beta cotangent. Like we can produce those kind of problem, right? Okay, so at first we just use the formula. Let's say sine alpha plus beta. So here we want to find sine alpha plus beta, right? So at first we have this formula: sine alpha plus beta equals sine alpha cosine beta plus cosine sine. So this is I just copied the formula. Okay. So in order to find this value, sine alpha plus this value, we need to find the sine alpha cosine beta cosine alpha sine beta. So we just need to find those things. Okay. So here, so we are giving two angles as alpha and beta. So if we know sine alpha's value, we can know this alpha's others, right? So those kind of problems, just like giving one, find others. So anyway, like, if you give me two angles, so our way is use large triangle. So let's say this angle, so we draw this large triangle. Suppose we say this is angle alpha, and we know sine's value, sine alpha equals 3 over 5. Okay, so we know this side is 4. Okay, so for beta, for angle beta, so we also use large triangle. Yeah, suppose this is beta. So for this beta, we know cosine value is 1 over 3. So here, forget a negative. Okay, 1 over 3. Then this one is let it go 8. Right? Okay. So from this, there's two large triangles. we can know the value for others. We can know sine alpha, cosine beta, cosine alpha, sine beta. We can know those values. Okay, and but also we need determine positive or negative. Okay, so let's check here. Let's say I just draw beta. Oh, I'm sorry, this is wrong. Yeah, the cosine beta. Let's say cosine beta. I made a mistake. The cosine beta is 1/3. So cosine beta 1 should be put here, 1/3. So this I put 1/3 being sine beta equals 3. So this is wrong. And this graph should look like that, right? 1/3 and radical 8. Okay, so this is beta. Okay. Okay, so we just plug in here. Let's say from the formula. So we put here. Let's say, I just I don't need to do those so many terms. I just check it from here. Okay, so sine alpha. Like I copy here equals sine cosine plus cosine sine. Okay, so what is sine alpha? So we can go to here, sine 3, 5. So this is 4. So sine value is 3/5. So this is positive, negative. So we need to know where the angle alpha is. So let's check here. It says alpha is in quadrant 4, or beta is in quadrant 2. So we know sine alpha in quadrant 4 is negative, right? So let's say that all students take calculus. So in quadrant 4, so we know sine alpha is negative. Okay. Then cosine beta. Cosine beta is 1/3. 1/3. So this cosine beta is positive or negative. So we need to check where is the location. Where is beta? So this is beta is in quadrant second quadrant 2. So we know cosine is negative, right? Cosine is negative. Okay. So plus, so cosine alpha is 4/5. I put it to here. Okay, cosine alpha, I put it to here. 4/5, right? So this cosine is positive or negative. So I need this information where the angle is. We say alpha is in fourth quadrant. So we know in fourth quadrant the cosine is positive. Okay, and let's say the sine beta. Sine beta is radical 8/3. So this sign is positive or negative. So I remember beta is in second, right? Okay, so sine beta is positive. Okay. Okay, so we get the final answer equals cosine alpha plus beta. This is negative 3/5 times negative 1/3. So this equal 15. 3/15, right? So plus, so this also same denominator, 15, right? 3, times 5, 15. So here's 4 radical 8. Okay? Okay, so we are done, right? Oh, 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 I'm sorry. I made a mistake. Let's say, uh, oh, for me, I made a mistake, right? Uh, so, uh, beta is in conjugate 2, sine beta is positive, not negative. Okay, so this is so also here we should be careful. Sometimes determine positive, negative, it can be confusing. Okay, so be careful. Even for me, I can make mistake. I can make mistake, right? I'm sorry, I made a mistake. So final answer should be plus. Yeah. Okay. Okay. So here, radical 8. We can simplify to 2 radical 2, right? So this one we can simplify to 3 plus 8 radical 2 over 15. Yeah. So for this one, simplify radical 8 to this is, if you can simplify, it's good, right? But if you keep radical 8, then it doesn't matter. It's okay. Okay. Okay, because here we do what we emphasize is apply the formula. Okay. Okay, so now we see we have many of those kind of problems. Okay, so we can produce many of those kind of problems. So let's check these examples. Like here, we want to find cosine alpha plus beta. So our first step is just copy the formula. Okay, so cosine alpha plus beta equals this. So copy the formula. So it's hard for us to remember those formulas. So I will print a. I will give you a formula sheet. So we will have many formulas. So it's hard for us to remember those things, those formulas. So we will. So in the exam, so you can use the formula sheet. So you don't need to memorize those formulas, but you need to know how to use those formulas. Okay. So since at first find the cosine alpha plus beta, so cosine alpha plus beta equals this. So then we need to find. So actually, like we forget this. So we just need to find each of them. So how can we find those values? So we use right triangle for angles. Let's say like for alpha, we have this information. Okay, so alpha. So I draw a right triangle. Okay, suppose this is alpha, and this sine is 4 over 5. So this is 3, right? So alpha sine alpha equals 4 over 5. So forget the negative. And beta, so this time tell me tangent beta. So beta is, we know, suppose this is beta, okay? So this beta, so tangent equal 5 over 12, okay? So if this is 5, this is 12, I know this should be 13. So here we can regard those two right triangles as also typical right triangle. So we can call those right triangle as integer right triangle. 3, 4, 5, and 5, 12, 13. Okay. Okay. So now let's say, so if we want to find those values, so we just say, oh, from these large triangles, we can easily know those values. Like let's say, so equal cosine alpha. Cosine alpha equals 3/5. Cosine beta is 12/13, right? But we also need to determine positive or negative. So maybe we should that we need to know where the alpha is. So I put it to here. Alpha is belong to fourth quadrant, and the beta belong to, let's say, a second quadrant. Okay. So I just use those things. Like all students take calculus. So use this to determine positive and negative. So alpha is in first quadrant. So cosine is positive. So we don't need to put a negative, right? Cosine alpha positive, but cosine beta is negative. Yeah, so negative. Okay. Okay, so minus. So this is minus. I just copy from formula. So sine alpha. Sine alpha is 4/5. But this sign is negative. Right? So negative. And the sine beta. So sine beta is 5/12. Oh, I'm sorry, 5/13. So this sign is positive. Okay, so no negative, right? Okay, so then I just put them together. So I say the denominator. So denominator should be the same. So like just 5 times 13. 5 times 13. 65, right? So this is the denominator. So numerator here is negative 3 times 12. 3 times 12 is negative 36, right? So here minus negative. So actually become positive. So equals this, right? Okay, so then simplify. If we can simplify. If we cannot simplify, then keep this. So this equals negative 16. Okay. So negative 16, 65. We cannot simplify for them more. So this is our final answer. Okay. Okay. So those kind of problems, we say at first copy the formula. Then give us two angles. So we just for the two angles, we just withdraw. We just draw this. Use these two large triangles to help us to determine the values, right? Then check a positive, negative. Where the angle is, so check a positive, negative, right? Okay. So for angles, we also can use arc sine, arc cosine. So those arc usually could use we just in the first quadrant. So we don't need to check a positive, negative. Okay. So for this one, let's say we want to find tangent arc plus arc. So here basically we need to find tangent this angle plus other angle. Just like this, tangent alpha plus beta. So what is alpha? Alpha is this angle. Alpha is arctangent 2. So alpha is this. Okay. Alpha is arctangent 2, meanings its tangent is 2. So we can put 2 here, 1 here, and then this one, let it go 5, right? So this angle, this alpha tangent is 2. So we call this alpha is arctangent 2. And the other one is arctangent 3. So suppose this is beta. Okay. So this beta, this angle tangent is 3. So I put 3 here, 1 here. So this angle tangent is 3. Okay, so if this side is 3, this side is 1, then use a square b plus b square equals c square. We find this one should be radical 10, right? Okay, 1 plus 9, 10. Okay, okay, so at the first we just apply the formula tangent alpha plus beta. So the formula is thus: tangent alpha plus tangent beta. Okay, 1 minus tangent alpha tangent beta. Okay, so this is formula. Okay, so now we apply the formula. Okay, so let's say so equal. So what is tangent alpha? Oh, tangent alpha is 2. What is tangent beta? Tangent beta is 3. Okay, 1 minus. So what is tangent alpha? 2. What is tangent beta? 3. So we find this equal to 5, and this is 1 minus 6, negative 5, right? So equal negative 1. Okay, so here actually for this problem, maybe we don't need to draw these 2 large triangles, because like here we do not only involve tangent, do not involve sine, cosine, and others, right? But draw those large triangles is our basic way to solve those kind of problems. If you give me an angle, I just draw a large triangle to represent this angle. Okay. So we have many of those kind of problems. Let's do one more. Let's say, so here both of them are tangent. So let's consider. So we can produce many of those kind of problems, right? Let's say, so it's easy for me to make some questions, like find sine arctangent 2, so plus so suppose it's a cosine. Okay, like those kind of problem, right? Find the exact value for this. So we say such a problem is just like sine alpha plus beta, right? So equal this is just like sine this angle plus another angle, sine alpha plus beta. So our first step, we say just copy the formula. So copy the formula. So equal sine alpha plus beta. So this equals sine cosine plus cosine sine. Okay. So then we just need to find those values, right? So for this alpha beta, so we say what is the alpha? Alpha, so I draw large triangle. Alpha is those angle. Alpha is arctangent 2. Okay. This alpha the tangent. So there's angle tangent 2. So 2, 1, radical 5. And then for beta, beta is arc cosine 2 over 3. Okay, suppose this is beta. Okay, so for this beta, we know cosine value is 2 over 3. Okay, so 2, 3, then this one should be radical 5, right? Okay, so based on these two large triangles, so we can easily find those values for sine. So what is sine alpha? So 2 over radical 5. So here positive, negative. So occurs just positive. Yeah, positive cosine beta, cosine beta 2 over 3. So multiply, okay? So plus, so what is cosine alpha? Cosine alpha 1 over radical 5. What is sine beta? Sine beta radical 5 over 3, right? Okay, so we can add them up. So the denominator is just 3 radical 5. So here, so 2 times 2 numerator, 2 times 4 plus radical 5. Okay? So we are almost done for this problem, right? But mathematically, some people just don't like all radical. We don't like radical in denominator. So sometime maybe we will perform, or we will need to rationalize the denominator. We don't like radical 5 in denominator. So we want to get rid of the denominator. So we can use this. Like we just multiply radical 5. So radical 5, radical, this is become 15, right? Just multiply radical 5. So here become 4 times radical 5 plus radical 5 times radical 5 is 5, right? So we just multiply radical 5. So radical 5 multiply radical 5 equal 5, right? So this one, so is our final answer. So this one, and compare the two answers, same answer, same thing. But this one just looks bad, right? Okay. So we say those kind of problem, so easy. Like if we know alpha or beta given two angles, so we can produce their sum or difference. Okay. So use this method, we can produce many more typical angles. So for typical angles, we have those 30 degree, 45 degree, and 60 degree. Then from here, from applying the formula, we say, saying like this minus 15, so we can 15 is also typical degree. And if this plus this 75 is typical degree, we also can regard typical degree. Okay, and 45 plus 45, 90 degree is also typical angle. Or typical 90, we also can regard 90 is 30 plus 60, right? 30 plus 60, and 45, let's say like 45 plus 60 equal 105. So we also can regard 105 is typical angle. So from these three typical angles, we can produce more typical angles. So for 15 degree or 75 degree or 105 degree, for those angles, we can find exact value for trigonometric function without using calculate. Okay? So we also can regard those are also typical angles. Like for example, let's find this. Find sine 75 degree exactly. So exact meanings we do not use calculate. Okay. Okay. So at first we should know that 75 equal 30 degree plus 45 degree. 75 is the sum of the two typical angles. Okay. Okay. So sine 75 equals sine 30 plus 40. So at first apply the formula. So we have this, right? So sine alpha plus beta, sine cosine plus cosine sine. Okay, so we just need to know those values. So those values are before we are required to remember them. So to remember them is maybe not so easy, but we can easily remember there's two large triangles. Yeah. So like there's two typical large triangles. 45. So this is 1, 1, let equal 2, right? So this large triangle you should remember, right? The other one is this. Okay. 1, 2. So this actually comes from this equilateral triangle, right? 1, 2. So this is 60 degree. This is 30 degree, and this is radical 3. Okay. Use this. Okay, more clear. Okay, 1. Okay, 1, 2, radical 3. So this is 60. This is 30. Okay. Okay. So based on these two large triangles, we can easily find those values. So what is sine 30? So check here. Sine 30, this angle of sine is 1 over 2, right? So sine 30, 1 over 2. Cosine 45. So cosine 45 equal 1 over radical 2. Also here, maybe we just don't use this here. 1 over 2. We just use this just based on those large triangles. This 1 over radical 2, right? Plus, so cosine 30. So cosine 30 is cosine. So this angle is cosine radical 3 over 2. And sine 45 is 1 over radical 2, right? So based on these large triangles. Okay, so then this one, okay, equals, so denominator is 2 radical 2. So here's 1 plus radical 3. And so if we don't like radical 2 in denominator, so we want to get rid of this radical 2, so we just multiply radical 2, right? So 2, so radical 2, so multiply radical 2, the denominator becomes 4. So 1 times radical 2, so radical 2 plus, so then this radical 3 multiplied radical 2, so equal radical 6. Okay. So use the same way, like we can easily find cosine, like cosine 75 and tangent 75, or like sine like 15 degree, right? Cosine 15 or tangent 105. Those kind of problems are quite the same. Okay, so we will not. So we just use this one example. We don't need to repeat. No, all those examples are quite the same. Okay. Okay, so we say that today's topic is those formulas. Today's topic is sum or difference formulas. So we say just use these formulas. And so we don't need to remember this formula. We don't need to derive this formula or prove this formula, but we do need to use these formulas. Okay, so use this formula. So we just okay. So we say like give me two angles. Just give me two angles. So ideas draw. If we give me two angles, so we should use draw these two large triangles. So help us to find the values. Saying use this, like all students take a calculus, use this to determine positive or negative. Okay, okay, so this is today's topic. Okay, so thank you for watching, and happy Thanksgiving. So enjoy your Thanksgiving break. Okay. 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 Happy Thanksgiving. So bye bye.